give us the first three.
Okay. You see, to understand the BGP's path selection using attributes, we were using this topology, and our testing was from autonomous system 10 to the destination 78, 78, and 87, 87.
Right.
The 77, 78, and 87 is coming from two different autonomous systems. One is originating from 50, another one is redistributed from 40. Originating and redistributing is not same. Originating means advertised BGP's own network. It is advertised in BGP. The other one is taken from the other source, maybe connected or other routing source, injected into BGP. So we have done weight, local preference. I just want to remind you once, and then I want to take you to the side of community and teach you what community means and where it fits. See, a community uses attributes, but attributes are those 13 things that we saw. Do you remember this attribute in sequence, in order? Yes, path, and comes lowest origin code. You said MAD after AS.
Okay,
yeah.
Okay.
And then only comes MAD. Then only comes MAD. And then EBGP. EBGP neighbor given routes are preferred over IBGP neighbor given routes. If both are IBGP, then the closest IBGP neighbor. Using IGP, we measure that IGP protocol like OSPF given metric. And then oldest EBGP path, and then the lowest neighbor route ID. Even if there is a tie in this, then lowest neighbor IP address. So these 11 is more than sufficient to pick one best path among many paths to a destination. So BGP never does load sharing by default.
Right.
Now, where is this community coming into picture? Remember, yesterday you gave me a scenario like I have two ISPs. Both the ISPs are giving me routes to reach the internet, and I want to do the load sharing. I want to do load sharing between these two ISPs. Correct, right? That's what your expectation was.
Right.
I was telling you to achieve that, you need to identify those networks that needs to go via ISP1 and group it and set some weight or a local preference or some of any one of this attribute. You see, you need to group it, isn't it? There are, as you said, there are thousands of networks coming from the ISPs. Right. How do I know which one to send? How do I share the load? How do I identify? Okay, for that answer is this. You see, when you take such connections, ISPs, when you take BGP connection, they will give you some community tags. Whenever you say, I'm having two ISPs, for example, you are talking to ISP2, they will ask you, do you have any other internet connection? And you will say yes. Oh, in that case, we'll give you some tags. it will give you some tags. You may use the tags for selecting the path. So communities are nothing but tags. Communities are nothing but markings. Communities are nothing but classified. You see, among 1,000 network that is coming from ISP, you have a marking, you have a classification, you have a tag to identify some hundreds of destinations. Among 1,000, you have some hundreds identified with one single tag. If you take the tag and set weight, all 100 destination will have that weightage. That tag is what community. The tag is what community is. And this tag ISPs give you. And you use it. Or you can use predefined tags, predefined community values. What is predefined community value? For example, I do not want all the private networks to get advertised. Very simple. You don't need to write too many filters to filter the private networks. You simply use the community local. Or you simply use the community internet. Only internet networks will be advertised. No local network will be advertised. So communities are nothing but tag values. We can simply call the tag and say if this tag is matched for those destinations, this is the weightage. If that tag is matched, that is the weightage. So when you do like that, it will be easy for you to have multiple paths to share the load as we saw in the previous yesterday's lab. You see here it talks about community values. Community is a group of prefix that share some common property that can be configured with BGP community attribute. BGP community attribute is an optional transitive attribute variable length. The attribute consists of set of 4 octet value, means 32 bit. The tag value is 32 bit. That specifies community. Community attribute value is encoded with autonomous system number in 4 octets. Let me. Community can be okay. Community is like a flag. I told you it is a marking. In order to mark, you see, community can be used as a flag in order to mark set of routes.
Right.
I told you have thousands of routes. But you don't need to worry about thousands of routes because some routes, some hundreds of routes have got common flag, common mark, common tag, which is what called as community. Now let's go down. Okay, here they are showing you an example. This is the syntax of community. 100:300. 16-bit colon 16-bit. Okay, let us not get into the configuration part. I'm just trying to show you some default communities. See, in Cisco, it's very rare to see such document. In Juniper, you have very nice. When you say community, in Juniper, they will have very nice document. You had UK, you see. Okay. Now, this is a copied line from BGP. 32-bit, 16-bit value, colon 16-bit. Now, oh no. This is what I was talking about. These are all predefined communities. So you can also include the following well-known communities. They are called as well-known communities. If I use the community tag, if I use this marking no advertise route, this community name must not be advertised to other peer, meaning all the networks that are attached to this community value will never be advertised to any IBGP or EBGP peer. It won't get advertised. If I use this tag value, this community must not be advertised outside BGP confederation boundary. I have not taught you so far what is confederation. So we'll come back. No export. No export subconfigure is another value, tag value. Route is not advertised to EBGP, including the peer in other members of ASI. So it will not, if you use this keyword, it will not be advertised to other EBGP members. As I told you, they are not same for every vendor. They change from vendor to vendor. Let's do some more search on community. Oh yeah, this is again same. This is the term in Cisco we have. Let me use this in the paint. We have well-known 4 communities in Cisco. One is called Internet. Advertise the prefix to all BGP neighbor, including IBGP, EBGP, all neighbor. No advertise. Do not advertise the prefix to any neighbor, both EBGP and IBGP. No export, which means you will not be able to advertise to EBGP neighbor. Local AS. Do not advertise the prefix outside of the sub-autonomous system. This is what called as confederation. Even Juniper had this. We saw in the Juniper. Okay, so I want to repeat again. Community is a tag. The community is a tag value. The tag can be well-known tags like this. Internet is a tag. No advertise is a tag. No export is a tag. Local AS is a tag. You can use any one of this well-known, or you can also use your own 32-bit value, 16-bit colon 16-bit, to include the attributes in achieving the policy in path selection. You understand, earlier I was talking about 32-bit value community. This is also another community. See, if my expectation is not to advertise to any EBGP neighbor, which community I should use?
To the top one.
No.
To any BGP, you said
I say
not to advertise.
should not be advertised to any BGP neighbor.
I use no advertise.
Oh, what happened to you? I said only to eBGP neighbor. I don't want that to be advertised.
Oh, only to EGP neighbors.
Mm.
Oh, I think I said to any. Oh, I said no export.
Yeah. So when I use the keyword no export, it will advertise to all IBGP neighbor, but don't advertise to eBGP neighbor. See how easy it is to filter.
But can you advertise? Can you advertise only to IBGP and not EBGP? The other way. Can you advertise the other way around?
Other way around will not be useful. Listen carefully. Listen carefully. Other way is not needed. Listen carefully. This is going to advertise only to IBGP,
Okay.
not to EBGP. This is what we will need it. See, we have some networks and we want to keep it for ourselves. We do not want to give it to EBGP neighbor. For example, listen carefully. You have two edge routers, edge 1, edge 2. And you got ISP giving advertise networks here. This is your organization. Listen carefully, very important. These are all real-time examples. Now, this is ISP1, let's say AT&T. And this one, let's say MTN. Now, will you allow AT&T given network to be advertised like this and like this to MTN?
No.
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 You want to take from MTN, you want to take from AT&T, and you want to use it. You will not be allowing them to use your resource to exchange their routes. You won't, right?
No.
You won't. So what I can do is, whatever I learn from here, I'll say no export, which means it won't give it to AT&T. Whatever I learn from AT&T, I'll say no export, which means it won't give to MTN. You understand?
Yes.
But if you have another neighbor here, it will go there. IBGP neighbor. It will go to IBGP neighbor, but it won't go to MTN.
Right.
Why there will be a other way around needed? You tell me. Why there will be a
No, I
need for?
don't need it. No, I don't need it.
That's why we don't have such community. But if you want to have that also, you can do it manually. You can use that number, and you can use the community tags, that 32-bit community tag, 16-bit colon 16-bit community tag, and map those networks that you want to advertise to eBGP, not to advertise to IBGP.
Right.
That you can do manually if it is needed. But most of the time in the real world, that is not needed. That's why we don't have such well-known attributes. We have only this 4. Now, let us go back to our normal plus here.
Yes.
We'll talk about community later again after finishing this attribute. I'm going to teach you this one called route reflector, followed by configuration. After that, we will learn community.
But didn't you teach me road reflector already?
If I have taught you, but still I want to teach you one more time before teaching community because they are connected.
Okay. That's fine.
They are
That's
somehow
fine.
relate. They have some relation between them. So I want to teach one more time, remind you those things that we learned. And
Okay, that's fine.
I'll take you to community. Sorry, I'll take you to after route reflector. I'll take you to configuration. Okay. Here we go. In our topology, when I go to router 1 and see, I should see some routes to reach router 7 network and router 8 network. So when I say here, show IP BGP, I can see 1.1. Oh, very sad. I don't see anything learned here. I'm just
This
advertising
is
my
local.
local. Now let us see why I'm not seeing it. Let's find it out. Okay, in router 2, when you see show IP BGP, even here you don't have. Okay, so R2 is not receiving routes from R7. What about R3? Show IP BGP. Oh, even here I don't. Oh, what happened? Let's go to router 7 itself. Show IP BGP. This has learned 1.1.1.1. That's a happy news. We are learning this 1.1.1.1 from router 7 as well as from router 6.
6, right.
It goes via router 6 because of the less AS jumps than
Right.
going via 7. We are checking this on router 8. So which means router 7 and 8 are not advertising any network. They are not advertising these two networks. Shall we advertise them? Now,
Sure.
I'm going to use the network command to advertise on router 8. Router BGP, I think 50. Router 8 is 50, yes. 50. And I'm going to say the networks are 78. Mask.
And I can stay a little bit longer this morning because I'm going into work later.
Okay. Network 87. Mask. No. You see, we got these two advertised, not redistributed, advertised. I'm also going to router 7 and I'll say access list.
BGP 40.
No,
Access list, okay.
because I want to advertise this one by redistributing it. So I want to use the access list and say only these two you can redistribute.
Okay.
Access list 10 host permit host 78.78.78.78 and okay, these two, what we are going to do, router BGP 40, redistribute connected, but only the access list.
Well, we didn't create a route map.
Yeah, we need route map. Let's go to route map. Route map. Redistribute. Match IP address 10, which is access list number 10. And now I'm going to say router BGP 40. Redistribute connected using the route map red. So there are two servers for this two network 78 and 87, but one is I, another one is question mark. Let us go to router 1 and see what it is able to get. Yeah, same like what we discussed here. It is learning from 2 to 2 with question mark. It is learning from router 6. This is router 6 with I. But why it prefers question mark, you know? Because this is an unreachable next stop for router 1. Because we have not said next stop self. In router 2, we have said next stop self. We are seeing next stop as 22222. R1 can ping this next stop. R1 can ping this next stop. That is the reason why, even though it has got question mark, it is using this. But now what I'm going to do, I'm going to go to router 3 and change the story. What? Router BGP 10 neighbor one next hop self. After I say this, now you can see it has switched to router 3 because I is preferred over question mark. But for that, the tie, if this need to be matched, if attribute 5 need to be matched, if this need to be a tiebreaker, there should be a tie in the above. Let us check. Do we have a reachable next stop? Both are reachable next stop, so that's a tie. The first point, 0th point is tie. First point, weight. Do we have same weight for both? Yes.
Yes.
Do we have same local preference? Yes.
Yes.
Do we have any 0000 for this as a next stop local origin? No. For 78 and 87, there is no local origin. Okay, no local origin. And then what about the AS? This is also 2 hop. This is also 2 hop. So AS is also a tie. That is why it comes here as a tiebreaker. The lowest origin code. I is lowest than incomplete question mark, isn't it? So this is a tiebreaker. Show IP BGP, show IP route BGP. You can see the traffic is going via router 3.
And incomplete just means it was advertised via redistribution.
Yeah.
Okay.
It is not advertised, it is redistributed. Advertised means using network.
Right, it was redistributed.
Yeah.
Right, it was redistributed.
Yeah. Fine. Now, somehow we got the route. Not somehow, we saw how we got the route. There is a logic. Now, going back to our learning. Now, what if I set weight on R1 saying R2's weight is more? Then automatically traffic will go via router 2.
Yes.
Even though path via router 2 is taking to R7 where the network is redistributed, because this attribute comes first, weight comes first. Before any other attribute, weight comes first. So how do you do that? How do we do that? We cannot do it on router 2 or router 3 because we know that weight is local to the router. Only on that router where we configure, you can see the expected result. So if you want R1 to decide to go via router 2, right now it is going via router 3. If you see the routing table there, VR3.3.3.
Yes.
But if you want it to go via router 2, what we need to do? We need to set weight. Very simple. Because your aim is very clear. Your expectation is R1 alone need to go via router 2. R1 should go via router 2. There is no big objective. There is nothing like, I don't know, I want every router in this autonomous system to go out via router 2. That's not your aim. Your aim is any traffic coming to R1 with the destination 78, 78 or 87, 87, they should go via router 2. So how do we do that? Router BGP 10 neighbor 2.2.2.2 wait, simple.
Wait.
There is no need of route map, anything. Why? Because we don't have some networks to go via router 2, some networks to go via router 3. Our aim is all the destinations should go via router 2. If router 2 path fails, only then it should use router 3. Only if router 2 path fails, it will go via router 3. Yeah? So,
Yes.
let us set some weight. I'm going to set weight as 80, simply. 0 is the default weight. I'm setting weight 80.
Yeah, but
What is the
can I
meaning
say
of
something?
this? Okay, come again.
Can I say something?
Yes.
But even if you didn't set the weight,
Hmm.
if router 2 fails, everything will still go to router 3.
You see, listen. Our aim is router 2 to be the primary path.
Right.
Router 3 need to be the backup.
Mm-hmm.
But right now, when you, before setting weight, if you see the backup path is being used, not the primary path.
Yes.
Now, because I set weight, I'm able to push the traffic now via the primary path.
Oops.
Yeah, I'm able to push the traffic via router 2 because I set the weight. If I didn't set the weight, this is not possible. And now if you see show IP BGP, you can see the weight is set 80. That is the tiebreaker.
Right.
Now if router 2 fails, definitely it will come to router 3. Let us check it. Let's go to router 2 and shut down these two. See, I'm not shutting down the directly connector. I'm shutting down these two links. You see what happens. Or I'm going to shut down the R7. You see what happens. You understand what I'm saying? I'm going to shut down.
Yes. F00.
I've shut down R7 F00, which is the original source for router 2 to receive.
Yeah.
Now you will see soon it will switch to router 3 automatically. The notification should come. Maximum it will take 3 minutes. 3 minutes. Maximum. 180 seconds is the maximum for timeout. But in the real devices, it will come very fast. Here it will take some time, but it won't take more than 3 minutes. See, notification should come from here to here. And this guy should forward here. Still it says I'm going where router 2. But sooner you will see it will go where router 3 very soon.
Okay.
It will take time. If you want immediate impact, then I need to go and refresh. I just want it to be natural.
Right.
If I go and refresh on R4, then it will happen. But in the real world, you will not have access to R4.
Exactly.
So this delay will always be there in the real world. BGP is a slow protocol. Let's go to router 4 and see whether router 4 has learned that the neighbor is...
Get notification.
down. Router 4 still believes router 7 is alive. That's the problem. It's a simulated environment. In the physical environment, as soon as this shut down, here it will notify line protocol down. Immediately this will take a decision. But here, it is waiting for that 180-second timeout. This guy is still thinking that it is there.
This is up, yes.
But when I say clear IPBGP star, then it will not C7. C7, 5 and 2 will come. But
yeah, 5 and 2 came up.
No. It went down. Where did 7 come?
No, 5 and 2.
Only, only 5 and 2 will come up. 7 is not going to come up. Because we have shut down that port, right? Now you see on R1, it knows that it is gone. You see? In the real world, this is how the failover happens. The primary has gone down, so it's taken the backup path. Now let us bring that primary path. So it's not only your immediate ISP, even somewhere in the remote, like R7, when it goes down, you will have the fallback. It will come now. You see, it will come and say, I'll go via 222 because we have set wait. Yeah, that will not be removed. That wait that you have set is still applicable.
Right.
When the notification comes, see, it has come now back. It's going back via router 2. Yeah. So this is what almost similar to what you are asking in the previous class. Yeah. Now let us do something like this.
But remember, each ISP is giving me 2 paths.
What? 2?
Each ISP is giving me 2 paths, so I have 4 links.
Okay. Yeah.
So
between that
ISP,
you want
I have
backup.
a primary and backup.
That's a very high available network, reliable network, highly reliable network. That's good.
Yes, but the thing is this, it is not being utilized properly because the backup part. All right, the backup part has to be manually, because I came on just recently and I said they have to manually switch over to the backup part.
That's a very bad idea.
Exactly.
That's
very bad. It's terrible.
No need. BGP will do automatically. There is no need for manual. So something is wrong in their configuration. That's wrong.
Yeah, it is totally wrong.
Something is missing in their configuration.
No, the person who designed it, they didn't know what they were doing. No, it's true.
I also say the same, yes.
Yeah, they didn't know what they were doing.
Correct. When was that deployed?
When? I'm not sure. It was
maybe very long time.
3 years ago?
No more.
3 years ago, yes.
3 years ago is not too long for BGP. See, people were having less knowledge on BGP like 15 years back. If it is deployed in the 15 years back, in the initial day, we can accept this, but not now. Now, if they say
it was deployed about maybe 3 years ago or 2.5 years, maybe about 2.5 years ago or less.
Then it is a poor design, poor configuration, poor configuration.
Yes.
Okay. So now let us now do something like this. You see, we are going to do load sharing. Using route map, we can do that. Yeah, right. I can have 87 to go via router 2 and 78 to go via router 3. How to do that? How do we do that? Route map. So I'll go to BGP and remove this global configuration for wait. I removed this. It was global for all destination. I don't want for all destination to go via router 2. I just want only for 87. Clear IPBGP. Show IPBGP. Now all going to go via router 3. It is because of I. Now I want for 87 to go via router 2. For 87, I want the next stop to be 2.2.2.2. For 78, this is okay. But for 87, I want it to be 2.2.2.2. Please help me to do this. How to do this?
Okay. So we go into router 1, create an access list that identifies.
Wait. We have a very good flexibility to jump into this device, right? Can you jump into this device? No. Sorry, this is in my laptop. Even though I'm accessing the same server, but this is in my laptop. Okay, no problem. Now I'll do that. What do you? Sorry for that. Sorry for stopping you. Please tell me what I should do. I want
create an access list.
Okay. Access list.
Identify that route. That permit that 87.
Okay.
And then you create a route map.
Okay.
Give it any name, your number.
Okay.
And then you match that access list, match IP address 10.
Mm-hmm.
And then you set the weight for that.
Yeah. We need to set the weight here itself. So let us give 100.
Right.
Okay.
And then you create another one to create route map with a different sequence number, and then that's it. You're going to match that inside BGP.
Okay.
I'm going to call it inside BGP.
Router BGP 10. Okay.
And this is neighbor. You see, want it to be 3. It's a neighbor 3.303.
Nope. Why?
Which one you want it to be?
It's already going via 3, no? See? Show
wait. 2.2. Oh.
Yeah.
Okay, well, neighbor 2.2.2 then. Route map. And the way to call it. WE, I think. WEG.
And then?
And you want it in.
Yes, as the update comes in, I want to add the weightage as 100. And here you can see now, only for 87, it goes via router 2, and for 78, it goes via router 3.
Yes.
Like this, we can also do for the entire autonomous system. This is only for this router. What are we going to do for that?
Again?
If I want to do this type of load sharing for every router in this autonomous system, not just for router 1, for router 2, router 3, any router in this autonomous system should take these paths. 87 should go via router 2, 78 should go via router 3. What should we do? I repeat, I want router 2 to go via router 3 in order to reach 7878.
You want router 2?
I want similar path selection. 87 going via upper path. 78 going via below path. Even router 2 for 87 it should go via upper path. And for 78 it should go via below path. What should we do? Set local preference. Wait is only for that router. What we set is wait. It is only for that router.
Right, okay. Yes.
So, local preference, you can configure on any router, it gets distributed to other routers. Please focus. Right now, if you go to router 2, show IP route BGP, it says for both the network, I'll go via router 4. Yeah? And in router 3 also show IP route BGP. For both router, I'll go via router 6. So, router 3 and router 2 are not same like router 1. Listen carefully. Router 1 will say, I'll go to router 2 in order to reach 87. Yeah? But
Yep.
for 78, it is going via router 3. I don't want R2 to go via the upper path for both. I want same like router 1. Only for 87.
Oh.
For 87, it can have this next hop. I don't have any problem. But for 78, I want this to go via down
Router 6.
Router 6.
Yes.
To achieve that, instead of writing wait on every router, you can use local preference. And that local preference you can configure on router 2 or router 3 or even on router 1. Even on router 1, let's go and do. First of all, I want to do and show you. I'll go to the route map. I remove that, I remove the wait. Sequence them.
Go into the route map first.
Okay, I remove this wait.
Yes.
I remove this wait. Instead, I say set wait
No.
200. Sorry, set local preference
Local preference.
200. That's it. All right. Clear IPBGP star soft. Now show IPBGP. You can see here 87 is going by upper path. Now let's go to router 3. Router 3 earlier it was going for 87 below path, but now it go. I need to clear IPBGP star soft. Also tweet on router 2 clear IPBGP star soft. Okay, let's go to router 3 now. Show IP route BGP. Show IPBGP. You know why? The problem is router 2 and router 3 are not neighbor.
Right.
That is why. So let us form neighborship between router 2 and router 3. Router BGP 10, neighbor is 2.2.2.2, remote AS is 10, neighbor 2.2.2.2, next hop self. Likewise, go to router 2 and say router BGP 10, neighbor 3. You understand what I'm doing now? Why I'm doing this, right?
Yes. Yeah, you're forming neighbor
Remote
between
AS
three, so you
10,
can see them.
neighbor 3333, away remote next hop self.
Next up, sir.
Oh, I didn't say update source loopback 0. They are from loopback. No, router BGP 10, neighbor 2.2.2.2, update source loopback 0.
Same thing in router 3.
Oh no. No. Router BGP 10, neighbor 3.3.3.3, remote AS 10, neighbor 3.3.3.3, update source loopback 0,
No, that's network.
neighbor
That's network. That's network. That's
3.3.3.3,
putting right there now.
next stop self. What am I doing?
Just
Something is
show
wrong.
IP BGP summary and see if it sees it.
Show IP BGP. Now you can see 78 is going via router 3, where, okay, both are going via router 3. We need to wait some time for the convergence. Show IP BGP. Still this has not received the update. Show IP, let me try pinging 2.2.2.2 with the source 3333. Okay, now show run section router BGP. Okay, what I missed is update source loopback 0. Yeah, so I'll say router BGP 10 neighbor 2.2.2.2 update source loopback. Okay, now you will see the update going and coming. Clear IP BGP star soft. Show IP BGP. Welcome. Okay, I know why it's not coming. There is one more issue. What is that issue? See, it is not showing router 2 at all. What is the issue?
Sure.
See, router 2 can see from router 3. And router
Not seen
3
from router.
is not seeing. The reason is a route learned from one IBGP should not be given to another IBGP. So you need to have a route reflector client. Router BGP 10 neighbor 2.2.2.2 route reflector client. Any one if you say it is enough, no need to do it for 3 also, but nothing wrong if you do it with router 3 also. Okay, now let us go and check. I set local preference 200 on R1. Show IP BGP.
I didn't see a local preference 200.
Wait, something is happening in the background, I believe.
Look back at the configuration.
So instead of writing it on router 1, then let's do one thing. Instead of writing on router 1, let us do it on... wait, did I add the show 1 section router BGP? If you see here, we have a route map. Okay, in is the problem. In is the problem. You should set out. You are going to give 200, and you need to set it to router 3. Router BGP 10 neighbor 3.3.3.3. Whenever you advertise to this guy, use the route map. Wait in the way we really don't have it. We have local preference actually. We set. I need to say
take
out.
the next one off.
Clear it. That's not necessary. Let's check. Show route map. What is the route map says? Wait. Okay, local preference 200. Fine. Show IP BGP. Go to router 3. Show IP BGP.
But there is a command that says in on the same and router 1.
Let me remove that. Router BGP 10 I need to remove this.
Clear.
Okay, don't waste time like this. Better, I was just giving a try. The best approach is not this one. You need to do it on router 3 or router 2 to achieve this. So I'll go again back to BGP. I remove
Okay.
those route map statements. That's waste of time. I'll simply do it and show you in a simple way.
But you know, let me say this. It is better to make these mistakes or make these go over. I prefer that. But when some vendor, they do the pre-configuration and everything works perfect. Never see a mistake. You don't know what to expect. Everything has worked perfect. They show you these Yes, I don't like
That
that.
is commercial. They have time limits. They don't have enough time. They have time limit. Within the time, they want to make the big money, and
Yeah,
then they
but
want to take it to home. That's all. They don't care about whether
you don't
they get benefited,
student doesn't
whether the
understand
life
that
is
kind of
going to
stuff.
be
I don't
changed.
understand it a lot of time.
They don't care. They are not trainers. They are business people. Now let us go to router 2. Easy. As I said earlier, we want 87 to go via upper path. 78 to go via below path. Right now, both are going via upper path in router 2. Show IP route BGP. Right now, both are going via. Wait a minute. Why both are going? Okay, it is because of EBG question mark or this one. Right now, both are going via router 3.
This I,
It is
that
because
I
of this
is lower than the question mark.
I. It is because of the I. It is because of the I. You know why it is learned 2 times? Because we also use router reflector, not needed. Why it is not needed? Because we have direct IBGP connection. You have any one, no need both. That's the mistake I have done. Router reflector is not needed. Okay. Now you don't see the duplicate. It's going via I, but our aim is only for 87 it should go at upper path. Not only router T, 87 should go via upper path and 78 should go via the below path. How do we do that? Access list.
No, you should set permit first.
Okay. Now route map, I'm saying upper path 87. Match IP address 10. If match happens, set local preference 200. And the other things are as usual, no need to do anything, any changes. Okay, now you see, this is the important part. Where do you bind it? In or out depends on which neighbor you are binding it to. Show IPBGP, I can bind it to 4 and say in, or I can bind it to router 3 and router 1 both and say out. If you say out, then you need to do it for 2 neighbors. Better I'll say in. Router BGP 10, whenever you get update from this guy, and if it matches the route map,
Up 87.
Route map name. Did I create another? Okay, create. Route map this, and I'll say in. Whenever that guy gives you update, when it is coming in, you just add the 200. Show IP BGP, sorry, clear. Now you can see here, for 87, it is going via the upper path. For 78, it still goes via the below path. Show IP route BGP. Not only this router, even router 1 will go via the upper path for 87. Let's go and see. Show IP route BGP. For 87, it goes via upper path. For 78, it goes via below path. Not only router 1, even router 3 will also go. Router 3 also says for 87, I'll go via upper path because of 200, and 78, I'll go via below path.
So we use local preference.
Yep. So local preference is for the entire autonomous system. It's not just for
a local router.
One router. I did not configure, to achieve this, I did not configure anything on R7, sorry, R3 and R1.
Right.
I just did it on R2 only. I was able to achieve this just by doing
So
it on
R3 also?
R2 alone. Yeah, anywhere, anyone is enough. All right. So we have done this local preference, and you know what is local origin. Now, next is AS path. You see, I can use even AS path to achieve this. But this is the best way. What we have done is the best way. But you can also use the AS path to achieve this. How? Let me teach you how. You see, if I want the upper path for this, I can go and increase the AS hops for the path via router 3. If you increase the AS path, then automatically shortest AS path will be taken. Let me show you that. Okay, I want to show you that. First of all, let me remove the configuration that we did now. Remove it. Clear IPBGP star soft. Now if I check show IP route BGP, they both, for both the destination it is going via 3. But what I'll go do is I'll go to router 3 and write an access list, route access list 10
permit host.
And then I'll say this is the access list, and then I'll say route map upper for 87, and then I'll say match IP address 10. If the match happens, you see, set AS path prepend. I'm saying prepend some number as a AS path. It can be a number in this path or in this path. I'm just going to prepend 32 times. 30, 30. Prepend this so that it will appear like a more hop. Got it? And this is sequence number 11 for the rest of the networks. Now we need to apply this router BGP 10. Whenever you receive an update from 10.36.0.6, use the route map
in
this in a route in. Clear
Oh, star?
IP route star. Yeah, I forgot to say, sorry, clear IP BGP star site. Clear. Now, if you check show IP BGP, you can see the hops are increased for 87. So router 3 says, no, I will go via router 2 because the hops are less. But for 78, it says I'll go via the below path. Show IP route BGP, you see. For 78, it is below path. For 87, it is upper path. Let's go and check it on router 2. You see, for 87, it is upper path. For 78, it is below path. Let's check it on router 1. Yeah, for 87, it is upper path because less hops. 78, it is below path because it's less hop. That's it. So router 3 has got a poisoned
Yes.
path. Too many hops. That is how we poison it. Right. So we can use even the AS path attribute to manipulate. This origin code you know very well. Our next lab will be MED. Okay. That we will do it on